This is the homework for the evening of 10:13 for A days or 10:18 for B days. We're talking today about isosceles triangles. Isosceles triangles are special because two of their sides are congruent and their matching base angles are also congruent. Because of these congruencies, we can find the measure of missing sides and angles within an isosceles triangle. For example, in triangle 1, I have a missing angle at A, a missing angle at B, and a measure of an angle on the base at 70. If the left base angle is 70 degrees, how large would the right base angle be? It would also be 70 degrees. 70 and 70 is 140 degrees, so how many more degrees do I need? If you said 40, you are correct. There's still 180 degrees in a triangle. Number 3 is basically the same thing backwards. What we're going to do is we're going to take 180 degrees and we're going to subtract 52. That will give us the measure of A and B. Let's see. That's 128 degrees. Here's what's interesting. Because A and B are the same, I could rewrite this to say 128 equals 2A. A and B are the same. So what I wind up doing is dividing by 2. A is 64 degrees, and B is also 64 degrees. This idea of substituting values is something that you learned in Algebra 1. If B is the same as A, I can swap it out for the letter A. That's how I had 2 A's. Look at our next example. This is again an isosceles triangle. You may want to add all of these three up and set them equal to 180, but that would be incorrect. These are sides, not angles. But these hashes tell me something special about my triangle. It is isosceles. How would you set up this problem? You should set 11m minus 8 equal to 7m plus 20. The hashes mean these sides are equal. The 3m is not involved yet. Now we will solve for m. I wind up with 4m equals 28 and m equals 7. Now I could find the length of all three sides. 7 times n is 21 units. 7 times 7 is 49. 59, 69 units. 7 times 11 is 77. 77 minus 8 is also 69 units. Notice how these wind up being equal. That's exactly what we want in an isosceles triangle. The other kind of triangle we want to look at are equilateral triangles. Equilateral triangles are special because all the sides and all the angles are congruent. In an equilateral triangle, the measure of the sides the angles will always be the same. The measure of the angles will always be the same. That is not to say that A equals B equals C. It means in an isosceles triangle, these angles are always the same measurement. If they're the same and it adds up to 180, what would I divide 180 by? Angles in an equilateral triangle are always 60 degrees, no matter what. Let's take that idea and look at it in practice in some algebra. Here I have a triangle that is equilateral, means all three sides are equal. I need to find the measure of x so I can find the measure of the side. I already know how large this angle is because it is equilateral. What is the measure of an angle in an equilateral triangle? It is 60 degrees. This angle, 4x plus 12, is 60 degrees because every angle in an equilateral triangle is always 60 degrees. Now we do algebra. 4x equals 48, x equals 12. I can now use this x equals 12 to find out how long my side is. If x is 12, 2 times 12 is 24 units. We have one more example. This is a quick check to see if you remember what we've covered so far. Remember, in equilateral triangles, all of the angles have a certain measurement and all of the sides are the same. Try this last problem on your own, pause the video, solve it, and then turn the video back on. You should have said side A is 8 meters, side B is also 8 meters, angle C 60 degrees, angle E 60 degrees, and angle D 60 degrees. Do you see why my angles are all 60 degrees? In an equilateral triangle, the angles are always the same. Do you understand why A and B are both 8 meters? In an equilateral triangle, all of the sides are the same length. Make sure you take good notes so you can use these for our warm-up next class.